Hello, my name is Kuncheng. This is homework 6, problem 1 for presentation for stochastic process and the probability course. So let's do the problem 1. The problem 1, given fx equal to 1 plus xy over a and the absolute x less than 1, absolute y less than a, and also x and y have a joint density function. So for this function we can get the region of the x belong to -1 to 1, y belong to -1 to 1. So for first question we need to find a, so that the above defined is a valid joint density function. Means we have to do the integral fxy equal to 1, and let's do this integral. So the first integral we should be get like 1 over a 1 over a times 1 plus xy dx dy, and take 1 over a, take out of the integral, and we got, we have two integrals. And the first we can get x plus y over 2 from -1 to 1 dy, and we continue to calculate. We calculate from 1 plus y over 2 minus -1 plus y over 2, and we got 2 dy, and continued we got 1 over a, 2a from 1 to -1, we got 4 over a equal to 1. So we got a equal to 4. That's the first question to the problem 1. And let's do the second question is, are x, y uncorrelated? According to the lecture 6, we know if x, y uncorrelated, we have to, the definition is energy x times energy y equal to energy xy. Let's show this one is true or not. Okay, energy xy equal to, we can get function is integral. We have double integral, and xy fxy dx dy, and we take out 1 over 4, the quarter take out of the integral, and we have the function is double integral from -1 to 1, and we have the xy plus x squared y squared and dx dy. Let's calculate this one. We get the quarter integral y over 2x from 1 to 1 dy plus 1/4 -1 to 1. We have the also 3 y squared over 3 times 3 square x from 1 to 1 dy, And this one, easy to see, is 0, and we calculate this one is 1/9, and the energy is 1/9. And next we calculate energy X. We have easy to get integral negative double integral x times 1 plus xy over 4 dx dy, and we can get the first integral is x squared over 2 plus y over 2x squared from -1 to 1 dy. Because this one is odd function, so the integral should be 0. And because energy x equal to 0, so the energy x times energy y should be equal to 0, because this one is 0. But energy xy equal to 1/9, so energy xy doesn't equal energy x times energy y, so the x and y correlated. Okay, that's the second question. For the third one is are xy independent? Show your answer. That is easy, because for the second question we proved xy uncorrelated, and we have also x and y have a joint density function. So combine these two conditions, we can get the answer directly is xy are independent. Okay, that's it. Let's do the fourth one. The fourth one is find the joint density function of x squared and y squared. Okay, for that one, we can let z equal to x squared, w equal to y squared, and we have the determinant j equal to 2x, because that's a derivative z x. So similarly, I don't need to talk about that specifically, so let's continue. We got the number for the determinant. We got j equal to 4xy, and from this one, this capital Z, capital W, we have the small z equal to small x squared, and the w equal y squared. And because we have the square, according to these two functions, we have 4 roots. And we can talk about that. When z greater than 0, less than 1, w greater than 0, less than 1, and we got absolute j equal to 4 root z root w, and we can use the fundamental theorem, like fzw equal to fxy root z root w divide j, absolute j, and we have the 4 roots. And for the second one should be negative z negative w, or not negative, the w, we have the same thing, the absolute j 2. And similarly, we have the xy negative w. Oh, no. Positive z, negative root w. And similarly. And the last one is fxy, negative z, negative w. And divide j, 4, absolute. So we can easily to calculate. We got the answer is the here. And otherwise, that's for the situation for the here. Otherwise, we can easily to get when z less than 0, w less than 0, or ws, we got fzw equal to 0. And we can easily do, in summary, we can get the function is 2 plus not plus times that's the when that's for the z between 0 to 1, w between 0 to 1, and otherwise is 0. Otherwise, that's the fzw. And we can this one fzw equal to fz times fw, and we also can write fz equal to 1 over 2z and 0. We have the z between 0 to 1, and also we have the fw equal to 1 over 2 root w, and w between 0 to 1. And otherwise all 0. And according to the function fzw equal to fz times fw, so we can get according to the lecture and the definition. So z and w are independent, and z equal to x squared, w equal to y squared. So x squared and y squared are independent. So the last question is prove and disprove that x squared and y squared are independent. So this one is the answer. And the fourth question, we got the joint density function of x squared and y squared. So we have the function here, because z equal to x squared, w equal to y squared. So the function we also got. That's it. Thanks.